Good evening, class, or should I say good morning? Today, Monday, April 27th, we're going to start Chapter 6. And now I know this isn't going to be as exciting as if we were in the classroom talking about this, but I'm going to try my best. So this chapter is about data communication, delivering information anywhere and anytime. Data communication. It's the electronic transfer of data from one location to another. It enables an information system to deliver information. It also improves the flexibility of data collection and transmission. It's the basis of virtual organization. So it's really the basis of what we're all doing right now, being that we're doing school virtually and pretty much everything else in life we're doing virtually. It also provides e-collaboration. Google Classroom is an example of e-collaboration, as well as Google Meet, Zoom, GoToMeeting. They are all e-collaboration methods. So we're going to talk about bandwidth, which is the amount of data that can be transferred from one point to another in a certain time period. Attenuation, that's the loss of power in a signal as it travels from the sending device to the receiving device. Broadband is multiple pieces of data that are sent simultaneously to increase the transmission speed. Narrowband, that's voice-grade transmission of channel capable of transmitting a maximum of 56,000 bytes per second, so only a limited amount of information can be transferred. When I started using the internet back in the very late 90s, we had dial-up modems attached to our phone lines, and that is the maximum it was able to transmit, was 56,000. So you'd go to a web page, you'd type in the address, you would click enter, and it could take 5 minutes for the page to load. So that's why everybody, we wanted something faster, which is how we went into broadband, which is much, much faster now. The protocols, those are the rules that govern data communication. It also looks at error detection, message length, and transmission speed. We're going to look at input-output devices, or thin clients, which are used only for sending or receiving information. So those little tiny boxes in our classroom that we have that are our computers, they're a thin client. None of the programs are actually stored on them because all of the things that you access are stored on the network. So there's no processing power. A smart terminal performs certain processing tasks but is not a full-featured computer. Kind of like sheets, touch screens. That's what a smart terminal would be. An intelligent terminal, workstation, or personal computer, so that's just a computer, a laptop that you would have. A netbook computer is a low-cost diskless computer used to connect to the internet or a LAN. It runs software off servers and saves data to servers. So that's kind of what we have in school, only you can save to the little box, but it doesn't have a lot of storage. Mini computers, mainframes, and supercomputers. Processes, receives data, transmits it. I mean, it's pretty easy. And then there's smartphones, MP3 players, and PDAs. We don't even talk too much about PDAs anymore, which is personal digital assistants. That was your Palm Pilot or even a BlackBerry back then. But then BlackBerry made theirs into a smartphone. And so it was really just used for emails, and it was a cell phone that could get email or go on the internet. That's what a BlackBerry was. And they were huge. I had one back in 2000 and I want to say 2007, 2008. I liked it, but I only ever had one BlackBerry, and then I traded it in for an iPhone, and the rest is history. Video game consoles, they're another computer type of thing. Modems, they're devices that connect a user to the internet. So if you have cable internet from Service Electric, you have a cable modem. If you have Verizon Internet, you have a DSL modem. If you have dial-up, you would have a dial-up modem. It's short for modulator, demodulator, demodulator. Yep, fancy schmancy, modulator, demodulator, all that fun stuff, tomato, tomato. That will not be on the quiz. Well, maybe it'll be bonus. I don't know. Maybe. It's not required for all internet connections either. Dial-up, there we go. Analog modem is necessary to convert a computer's digital signals to analog signals. Then you have DSL, which stands for Digital Subscriber Line. Definitely know that one. Hint, hint. It's a high-speed service that uses ordinary phone lines. Then you have cable modems. They use the same cable that connects to TVs for internet connections. Cable modems are faster than DSL. No matter what Verizon tries to tell you, cable modems are faster than DSL. Especially if you live in a rural area such as where we live, the phone lines are so antiquated and old that they can't handle the highest speeds that DSL can be. So your best bet is cable modems, which is automatically going to be faster internet. They can be wired or guided. They can be wireless. Here is a diagram of types of communication media. So you can see there how it's either wired or conducted media or wireless or radiated. With the wired media, you have electrical conductors, which are wires or coaxial cable. We call it coax. Light conductors, which is fiber optics. So you've heard of that. I believe Verizon has that called Fios. Let me see if I can drag my screen down so you can see a little bit more of this. There we go. And then we have radio frequency, which is broadcast, spread spectrum, cellular, microwave, and satellite. And then under light frequency, we have infrared. We're going to have two slides on networks. We have a network interface card, the NIC. That allows a device to get on the internet. So my mom had purchased a laptop back in 2003, and it didn't come with a NIC, a network interface card. So what that meant is she couldn't get on the internet with it unless she would have one installed in it or have an external NIC. And I kept trying to tell her that, but she kept trying to plug Ethernet and everything into it. And I said, Mom, you just can't. It doesn't have anything capable to connect to the internet. It would be like not having cell phone service or not having a send button on your cell phone. You just can't. So it's the hardware component. Adapter, network adapter, it's also called. Okay, now we have LANs, WANs, and MANs. This is fun. A LAN is a local area network. So that would be like the school's network. It connects workstations and peripheral devices that are in close proximity. Then you have a wide area network that spans several cities, states, or countries and is owned by different parties. So you have to think of the internet for that one. And then you have a metropolitan area network, or a MAN. This is designed to handle data communication from multiple organizations in a city and nearby cities as well. Some cities have their own Wi-Fi, like a whole network in a city. Catawissa was looking into it at one point. There's a couple other communities that have it. But that's more like that, a metropolitan area network. And here's what a local area network looks like. You have the internet coming into a hub. The hub is connected to different workstations or computers and a server. So similar to what we have in school or even at your home. A wide area network looks a little bit different. So you have workstations connecting to servers and all connecting to the internet. So it's just wide. It's just a bunch of LANs all connected. And here you see the metropolitan area network. Similar to a LAN and a WAN. In fact, it contains LANs and WANs. Network topologies. This is how a network is physically laid out, including the arrangement of computers and cables. You don't even have to necessarily worry about this nowadays because a lot of networks are wireless, but it's very important to understand how networks are put together so you can troubleshoot in the event something goes wrong. So there's 5 common topologies: the star, the ring, the bus, the hierarchical, and the mesh. The star is a central computer and a series of nodes. So just like a star, the middle of the star, and then there's nodes that go out from it. Cable layouts are easy to modify, so it's an easy one to set up and modify. You have centralized control that makes detecting problems easier. You can easily add more nodes or computers or printers or anything to the network easily. It's easy to add to. It's effective at handling short bursts of traffic. Then you have disadvantages. If the central host fails, so if the server in the middle fails, the entire network is done. It increases cost. You need a lot of cables because everything is like a going to the middle server. So that, I mean, it's a good topology, but more for your home. Then you have a ring. You don't have a host computer. Each node is connected to 2 other modes, upstream and downstream neighbors. Transmission is one direction. So think of a one-way street. It needs less cable because you're only going one way. But diagnosing problems are difficult because it's kind of like a circle, a ring. It goes around and around. Like with a star, you know where it ends and where it begins, but with a ring, you don't know where the start is or where it's stopping. Bus topology connects nodes along a network segment. Ends of the cable are not connected. The hardware device at each end of the cable, it absorbs the signal. Advantages: it's easy to extend, it's reliable. The wiring layout is very simple, it uses the least amount of cable, keeps the costs down, and it's best for handling steady traffic. Disadvantages: it's very hard to figure out where something's wrong, and it can be a bottleneck when network traffic is heavy. Hierarchical topology. It combines computers with different processing strengths and different organizational levels. It's used by traditional mainframe networks. The mainframe computer is at the top. The front-end processors are at the second level. Controllers and multiplexers are at the third level. I'm going to keep going here. We don't have to get this in depth with this one. Advantages. Well, it offers a greater deal of network control and lower cost than Star. The disadvantages are network expansion may pose a problem, and there's a lot of traffic congestion. And then we have mesh topology. Every node is connected to every other node. It's known as plex or interconnected. The advantage is it's highly reliable. So if one thing goes down, there's so many other ways to get what you need. The disadvantages is that it's expensive. Imagine all those cables. Very difficult to maintain and expand. So this is the first part of Chapter 6 that we're covering this week. We'll have some questions throughout the week that you can answer. As always, I'm on Google Meet every Monday, Wednesday, and Friday from 1 p.m. to 3 p.m. The link will be in Google Classroom, as well as if you just go to Google Meet and type in Sahonic office hours, all one word, you will be linked into my Google Meet session. All right, thanks and stay safe. Bye.